Okay, namaste. All right, good morning, guys. All right, so here's what I have for you today. It should be a pretty easy day today. What I think I thought was valuable because we would have done this in class if we got on this simulation. It's kind of a Good Friday thing to do at the end of the year, also. All right, and I'm posting some questions that I want you to answer while you're doing this simulation, and so on and so forth. So the first thing I want you to do is you want to go to the University of Colorado FET. It's up there. You can see the URL, University of Colorado FET, and then simulation. So if you just Google University of Colorado FET simulations, it'll come up. And then you want to go to physics, and then you want to go to find this one here. It says Circuit Construction Kit DC for direct current. So you want to go to that, and what you're going to do is you're going to build a circuit. And the first circuit I asked you to build is a series circuit with 3 light bulbs in it. So I'm just showing it to you right now. Here, I'm on the simulation. It works on your Chromebook. So you should be able to do it. And what you do is you take, and there are wires up here, and you can pull them out, as Grandma Golis would say, like so, and then you can stick them together. I have like 3 together right now. You can also stretch them out, okay, like this. So I'm going to take this one. I'm going to stretch it down to here. Build myself like a little circuit. Okay, I'm going to take another little wire and put that right there. La, la, la. Okay. Okay. And then I'm going to put a battery. You have to have a battery, obviously, in it. Okay. In it. You could put 2 batteries in it, 3 batteries if you want. So, and by all means, fool around with it. See what happens. All right. And then I'm going to put a light bulb in here. Okay. Actually, what I'm going to do is I'm going to put a switch in here, okay, like that. And then I'm going to put a light bulb. La, 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 la. All right, I'm going to put another wire attached to that light bulb. Okay, have that. I'm going to squeeze that a little bit. There we go. So a little space. I'm going to put another light bulb in. And what I'm doing is I'm hooking up 2 light bulbs in series. Remember, in series is when they're in line with each other, like that. And there's only one path for the electricity to go, okay? In parallel is where you hook up 2 at a junction. And refer to the diagrams that I drew for you on the previous video on Ohm's law for series and parallel. And also, if you want to know like what parallel looks like, just look at the assignment you just did on Ohm's law, and some of the resistors are in parallel. And if you think about what's a light bulb, well, a light bulb is just a resistor. A resistor can be anything that uses electricity and disperses its energy. So it could be a light bulb, could be a refrigerator, it could be your hairdryer, okay? It could be your phone when you plug it in to get charged, okay? And now I'm going to complete the circuit. All right, I'm going to take this, kind of drag it like that, and then I can close the switch. There we go. Okay, and now the light bulbs have lit. Okay, and then I'm going to ask you to do several things in the course of doing this. Like for one, I'll say, what is the voltage drop across each light bulb? So you reach over here and it says voltmeter, and then you go, and then you take the probes, okay? And you can put the probes where you want. So I'm going to check the voltage across the light bulb. Okay. Now that's negative 4.5 volts. Don't worry about negative or positive. If I put the battery the reverse direction, it would come out as positive 4 or 5 volts. That negative or positive, that lesson is for AP Physics for those of you guys taking it. And we'll get into that more next year. But now that's opposed to if I take, now watch, I'm going to measure the voltage across the battery, and I think it's a 9 volt. Okay. Yeah, it's a 9-volt battery. So that means now voltage, again, we'll get more into this next year for the AP kids. For you guys who don't take the AP course next year, voltage is how bad, it was explained in the previous video, how bad the electrons want to get from one end of the battery to the other. Okay, so if you have a 1-volt battery, they only want to get from one end to the other so bad. But if you have a 9-volt battery, they want to get from one end to the other 9 times as bad. Okay, and voltage can be used up. Voltage is related to potential energy. And again, not for this course, but for next year's course. So what's going on here is when I register 4.5 volts across the light bulb, that means that that light bulb is using 4.5, about half of the potential energy of the battery, okay, or of the I don't want to say of the battery, about half the potential energy that the electrons have as they go across it. So what you can look at volts like this. So here's an electron, these electrons coming out of the negative end of the battery. It's almost like they're falling, okay? This is analogous to like potential energy, where you start at a high end and then the ball falls to the 0 point. And it's like you can look at it that way, like the electrons fall through the circuit. Except obviously the big difference is with a circuit, it's not just down. It's whichever way the wire or the conductor allows the electrons to flow. Okay, so and then I can take the probe and I can check it across this battery too, and so on. All right, and I'm getting negative 4.5. Now, what you're going to do is you're going to hook up like three. I think I asked you to hook up 3 of these bulbs first. All right, and check the voltage across them, and then explain what's going on. And I gave you a big hint and a half already in terms of like what's going on. I basically explained it. All right. And then what I want you to do is look at your schematics and hook up the light bulbs, 3 light bulbs in parallel. It's a little more complicated, but it doesn't take all that long. And then check the voltage drop across them and see what you're getting, and then see if you can explain it. Okay, and that's what I'm going to ask you to do. And then it says I'm asking you some questions, say like fool around with it a little bit, like put a resistor in the circuit somewhere, and this simulation, you can kind of, the guys who invented it had a sense of humor. All right, because you could put a dollar bill in there for a resistor, a paper clip, a coin, an eraser, and someone had a sick sense of humor, a human hand, a dog, a pencil. All right, so whatever, have fun with that, blow them up, do whatever you want. And I leave that up to you in the questions. The other thing that you could check, all right, is the current across each section of the. And what you do is you have to insert this ammeter in there. Okay. And it's giving me problems. Okay, but it's stuck. All right. Of course, this had to happen. Well, I'm going to cut it. Okay. So, all right. So you can put an ammeter in there. All right. And this does not look pretty, but it should work. Okay. So you could check the amount of current that is coming out of the battery, and I can check the amount of current through here, and so through any section of the circuit. Now, it will ask you to figure out, okay, I will ask you, how much resistance does each light bulb have? Okay, well, you notice that there's no resistor meter. Okay, so what do you have to do? Well, if you know the voltage, and I'll leave this up to you because you did a lesson on Ohm's law, there's a big hint. If you know the voltage and you know the current through each section of the circuit, you should be able to figure out the resistance. It should be a fairly simple calculation. So I'll leave you guys to that. Okay, so build your circuits today. Write up your answers to your questions. There's like 4 or 5 of them. Okay, and send them to me. And again, see me during my office hours at 10 o'clock. All right. Okay, so there you go. And I don't know how to turn this off. Do something like this. I don't know. Yeah, okay, here we go. All right, so have fun with this. Enjoy your apocalypse, and Golis out.